Welcome to the Anthropic Claude Certified Architect Foundations CCA-F Question Bank Series. In this video, I've got 10 exam-style practice questions lined up for you, covering the kind of agentic architecture, Claude code, prompt engineering, tool and MCP design, and context management scenarios you'll see on the real CCA-F exam. Each question comes with the correct answer and a full explanation, including why the wrong options are wrong. Here's how to get the most out of this. When a question appears, pause the video, pick your answer, then hit play to check yourself. Ready? Let's dive in. Question 11. An agent produces the correct final answer on most evaluation cases, yet in production it is slow and expensive. Reviewing only final answers has not explained why. What should be added to the evaluation? The correct answer is C, trajectory level evaluation that scores the sequence of tool calls and intermediate steps, not just the final answer. Final answer scoring is blind to how the answer was reached. Evaluating the trajectory exposes redundant tool calls, unnecessary loops, and inefficient paths, which is exactly where latency and cost originate even when the output is right. Now, why the other options are wrong? Per request latency and token dashboards broken down by customer is incorrect. These show which requests are expensive but not why, so the redundant tool calls driving the cost remain invisible. Human preference ratings on the final answers is incorrect. Preference ratings refine judgments about output quality. They say nothing about the number of tool calls or tokens consumed along the way. Stricter output schema validation on the final answer is incorrect. Schema validation catches malformed output. The output here is already correct. The problem is the path taken to produce it. Question 12. An operations agent has a tool that can delete cloud resources. The team wants to keep the capability but limit blast radius. Which control is the most effective? The correct answer is D. Scope the tool's credentials to a narrow set of permitted resources and require a confirmation step, enforced in the execution layer, for any deletion. Least privilege credentials mean that even a badly reasoned or injected instruction cannot reach resources outside the intended scope, and an execution layer confirmation adds a deterministic checkpoint. Together, they bound the blast radius regardless of model behavior. Now, why the other options are wrong? Add a strongly worded warning to the tool description about deleting the wrong resources is incorrect. Tool descriptions influence model choices but enforce nothing. A warning does not constrain what the credentials can actually reach. Log every deletion to an audit trail for later review is incorrect. Auditing is essential for accountability but is purely detective. It does not prevent the destructive action. Give the agent broad delete permissions, but instructed in the system prompt to be careful is incorrect. This is the opposite of least privilege. The capability to cause maximum damage remains, protected only by advisory text. Question 13. A team is building a feature that translates a paragraph of text into Spanish. There are no tools, no external data, and no multi-step decisions. What is the appropriate design? The correct answer is A. A single request-response call to the model with a clear instruction. Agentic architecture earns its complexity when the model must decide what to do next, call tools, or recover from failures. A self-contained transformation with no tools and no branching needs none of that, so a single call is the correct and cheapest design. Now, why the other options are wrong? An agent loop, so the model can review and refine its own translation, is incorrect. Self-review loops add latency and cost, and for a straightforward translation, they usually change little. Complexity should be added when there is evidence it improves the result. A multi-agent system with a translator agent and a reviewer agent is incorrect. 2 agents for a single-step transformation is unjustified overhead with no decision points to coordinate. A retrieval pipeline that looks up similar, previously translated paragraphs first is incorrect. Retrieval helps when the task depends on external knowledge the model lacks. General-purpose translation does not, and the lookup adds latency for little gain. Question 14. A user-facing assistant takes 20 to 40 seconds to complete a multi-step task. Users complain the interface feels frozen. The total work cannot be reduced. What is the most appropriate improvement? The correct answer is B. Stream output and surface intermediate progress, such as which step or tool the agent is currently working on. When the underlying work cannot be shortened, the remaining lever is perceived latency. Streaming tokens and showing progress gives continuous evidence that the system is working, which is what resolves the frozen complaint. Now, why the other options are wrong? Add a static spinner and leave the request non-streaming is incorrect. A spinner is better than nothing, but conveys no information about progress. Over 40 seconds, it does little to reassure the user that anything is happening. Return a partial answer after 5 seconds and discard the remaining steps is incorrect. This trades a real correctness loss for a responsiveness gain. The task legitimately requires all its steps. Increase the request timeout so the operation does not fail is incorrect. Timeouts are not the reported problem. The request already completes. This does nothing for the user's experience while waiting. Question 15. In a multi-agent support system, a triage agent hands conversations to a billing agent. The billing agent frequently asks the customer for information the triage agent already collected. What is the best fix? The correct answer is C. Define an explicit handoff payload, a structured summary of what has been established and what the receiving agent must do, and pass it on every transfer. Handoffs fail when the receiving agent inherits no reliable state. A structured handoff contract carries the established facts and the remaining objective, so the billing agent starts from what is known instead of re-interrogating the customer. Now, why the other options are wrong? Give the billing agent access to the triage agent's full raw conversation transcript is incorrect. This is better than nothing, but dumps unfiltered history into the billing agent's context, including irrelevant turns, and leaves it to rederive what was established. A structured summary is more reliable and cheaper. Merge the 2 agents into one so no handoff is needed is incorrect. This can be reasonable, but it discards the specialization the design was built for, and the underlying lesson about state transfer will resurface at the next boundary. Instruct the billing agent in its system prompt not to repeat questions is incorrect. The agent is not repeating questions out of preference. It has no access to the answers. An instruction cannot supply missing information. Question 16. An agent intermittently produces a wrong answer in production, roughly once in every 200 requests. The team cannot reproduce it locally. What instrumentation is most valuable to add first? The correct answer is D. Structured per request tracing that records the full sequence of model inputs, tool calls, tool results, and the final output. An intermittent, non-reproducible failure is diagnosed from the record of what actually happened. Full trace capture lets the team retrieve a failing request and see precisely which tool result or reasoning step diverged, without needing to reproduce it. Now, why the other options are wrong? Aggregate latency and token count dashboards is incorrect. Aggregate metrics reveal performance trends, but average away a 1 in 200 correctness failure. They cannot show what happened on the specific bad request. A higher log level on the application server is incorrect. Verbose application logs capture infrastructure detail, but typically not the model's inputs, tool results, and reasoning path, which is where the divergence lives. A synthetic monitor that sends one canned request every minute is incorrect. A fixed canned request exercises one path repeatedly and is unlikely to hit a rare input-dependent failure. Question 17. A request always requires exactly the same two steps in the same order. Look up a record, then format it into a report. There is no branching and no failure recovery beyond a retry. Which design is most appropriate? The correct answer is A. A deterministic two-step pipeline in application code, calling the model only where language work is genuinely required. When the sequence of steps is fixed and known in advance, encoding it in application code is more predictable, cheaper, and easier to test than letting a model rediscover the same plan on every request. Reserve model calls for the parts that need language understanding. Now, why the other options are wrong? An autonomous agent that decides each step at runtime is incorrect. Runtime planning is what you pay for when the path is unknown. Here, the path is fixed, so the agent adds non-determinism and cost while rediscovering a constant. A multi-agent system with a lookup agent and a formatting agent is incorrect. Two coordinated agents for two fixed sequential steps is overhead without any coordination problem to solve. A single prompt that asks the model to perform the lookup from memory and format the result is incorrect. Asking the model to recall record data from memory instead of looking it up invites fabrication. The lookup must hit the real source of truth. Question 18. An agent's tool calls a third-party API that returns rate limit errors during traffic spikes. The current code retries immediately and repeatedly, which worsens the spike. What should be implemented? The correct answer is B, a bounded retry policy with exponential backoff and jitter, falling back to a graceful, degraded response once retries are exhausted. Exponential backoff spaces retries so the dependency can recover. Jitter prevents many clients from retrying in lockstep, and a bounded count with a defined fallback guarantees the request terminates instead of hammering the API indefinitely. Now, why the other options are wrong? An unbounded retry loop with a fixed 1-second delay is incorrect. A fixed short delay with no ceiling keeps sustained pressure on a rate-limited service and gives the request no termination guarantee. Removing the retry logic so the first error is returned to the user is incorrect. Rate limit errors are typically transient, and a well-spaced retry often succeeds. Abandoning retries entirely degrades reliability unnecessarily. Routing retries through a second API key to avoid the rate limit is incorrect. Deliberately circumventing a rate limit shifts load rather than respecting the constraint and risks violating the provider's terms. Question 19. A team wants every engineer's Claude code session on a given repository to automatically know the project's build command, test command, and coding conventions, without anyone pasting that information into each conversation. What should they do? The correct answer is C. Commit a Claude.md file at the repository root describing the commands and conventions. Claude.md is project memory that is loaded as context automatically when a session starts in that repository. Committing it to version control means every engineer's session inherits the same project knowledge with no manual step. Now, why the other options are wrong. Ask each engineer to store the conventions in their personal user-level settings is incorrect. User-level settings are per person and not shared through the repository, so conventions would drift between engineers, and new joiners would start with nothing. Put the conventions in the repository's README and rely on the model reading it when needed is incorrect. A README is only consulted if something prompts the model to open it. It is not automatically loaded as session context, so the behavior would be inconsistent. Create a custom / command that prints the conventions when invoked is incorrect. This makes the information available on demand, but still requires someone to remember to invoke it every session. Project memory should load automatically. Question 20. A compliance requirement states that Claude code must never be able to run a command that force pushes to the main branch, and this must hold even if the model is instructed to do so. What is the correct mechanism? The correct answer is D, a pre-tool use hook that inspects the proposed command and returns a blocking result when it matches a force push to main. Pre-tool use hooks run before a tool executes and can deny the call outright. Because the check is deterministic code outside the model, it holds regardless of what the model or a prompt-injected instruction asks for, which is exactly what a compliance control requires. Now, why the other options are wrong? An instruction in Claude.md stating that force pushing to main is forbidden is incorrect. Claude.md shapes model behavior and is a good practice, but it is advisory context. It cannot enforce a prohibition against a determined or manipulated instruction. A post-tool use hook that detects the force push and raises an alert is incorrect. Post-tool use runs after the tool has executed. By the time it fires, the force push has already happened, so this detects rather than prevents. A custom / command that performs safe pushes, documented as the approved workflow, is incorrect. Providing a safe path is helpful, but does not remove the unsafe one. Nothing stops the underlying command from being run directly. And that's a wrap on this video. Nice work getting through those 10 questions. If this helped, you're going to want the complete set. All 390 exam-style questions, with full explanations across all 5 CCA-F domains, are available in my Udemy course, Anthropic Claude Certified Architect Foundations, CCA-F, 6 full practice exams. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 10 more questions. See you in the next video.